Hello, everyone. Uh, my name is Fikir Yilma. I will be presenting my AWS Cloud Computing final project. It is a hospital appointment scheduling system. In this presentation, I'll cover the problem I'm solving and the project objectives, the complete AWS architecture, a walkthrough of each services I configured, and a live demonstration of the working applications. So the problem we're solving is in healthcare appointment scheduling has several pain points. Patients often face long hold times while calling to book appointments. Scheduling is limited to office hours, and studies show that missed appointments cost the U.S. healthcare system uh, millions of dollars annually. My solution addresses these issues with a 24/7 online booking availability. It is a service provider search by specialty and insurance. It is secure with multi-factor authentication, automated appointment reminders to reduce no-shows, and a scalable serverless architecture that can handle varying loads. Uh, So what we're seeing on the screen right now is the architecture diagram of the application. Let me walk you through the architecture first. So the front end, um, this one, the browser is the starting point. Uh, Users they access this application through a React single page application. This is hosted on an S3 bucket configured for static website hosting. CloudFront sits in front of the S3, providing HTTPS encryption, global edge caching, and DDoS protection through AWS Shield. Authentication. When a user logs in, they authenticate through Amazon Cognito. I configured a user pool with email-based sign-up, email verification, and importantly, mandatory MFA using any authenticator apps. This adds a critical security layer for healthcare data. The API layer front, API layer front uh, communicates with the backend through the Amazon API gateway. I created a REST API with multiple resources for appointment booking management, for providers, for searching doctors, and for patients, for user profiles. Each endpoint uses Lambda proxy integration with course enabled for browser access. I have, as you can see, I also have 5 Lambda functions, all written with Python. Appointment handlers, the appointment handlers, they do CRUD operations for booking, provider handlers, search and queries availability. Patient handler uses profile management. A notification handler sends SNS messages. And the last one, the reminder handler, is triggered daily by an event bridge. The data layer is a DynamoDB stores all the data in 3 tables. So we have the patient table with an email JSI for lookups. We have a provider table with a specialty JSI for filtering, and an appointment table with 3 GSIs for querying patients, providers, or by status. Messaging, uh, we use Amazon SNS, handles notifications with email subscription for appointment confirmations, and the scheduling, which is the event which runs daily cron jobs at 8 a.m. UTC to trigger the reminders, the reminder lambdas, which checks for upcoming appointments. Now let me show you what I've configured in each service for in the AWS console. So to start with, let's start with the Cognito. So as you can see, starting with the Cognito, here's my user pool called user pool. You can see that, oh, sorry. Yep, you can see that MFA is required, and I'm using the TOTP authenticator apps, or I'm using the Google Authenticator app for, sorry. I also created a web client for the React application without client secret since it's a public client. So this is my Cognito page. For the Dynamo, so moving on to the Dynamo, here's my three tables. I've created three tables. Uh, let's just open the appointment table. You can see the partitions key. The partition key is the appointment ID. Under indexes, I have three global secondary indexes. The patient date index lets me query all appointments for a specific patient sorted by date. This is crucial for my appointment page. Um, and let's move on to my Lambda function. I have five Lambda functions. For demonstration purposes, let's just open the appointment one. The code uses the Boto3 to interact with the Dynamo DB. I have a function for get, create, update, and delete operations. It has the course headers in every response. This was critical for front end to do the work. Under configurations, as you can see, I have the timeout set to 30 seconds, and it is attached to the IAM role I created. So next, let's move on to the API gateways. I have created here an API gateway. In the API gateway, here's my REST API structure. Under providers, I have get method, then provider ID with another get, and availability is nested under that. Each method uses Lambda proxy integration. I want to highlight that the course configuration, uh, I enabled it on every resource and also configured the gateway response for 4xx and 5xx errors to include course headers. This was essential for error handling. The API is deployed at dev stage. You sniff the dev, but you can name it anything. So that's that. So next, let's move on to the yep. So this is my S3 bucket, and my S3 bucket is private. All public access is blocked. CloudFront accesses it through origin access control, which is more secure than the older access identity. So let's move on to the CloudFront console. Here's my CloudFront. The origin points to the S3 bucket. And as you can see here, it points to the S3 bucket here. And I configure the custom error responses here. Both the 403 and 404 errors return index.html with a 200 status. This is necessary for the React router to handle client-side routing. Let's move on to the SNS. In my SNS, I have my notification topic with an email subscription that I have confirmed here. And next, let's do event bridge console. So finally, the event bridge has a daily reminder rule using cron expression to run at 8 a.m. UTC, targeting my reminder Lambda function. So now this is the back end of the application. So now let's just go to the front end. Let's just sign out here. Anyone, so to create a new user, you just supply it with a new email password. You have to set up MFA, but I've already gone ahead and did that. So let's just log in through what I have already. So, I'm accessing this application through the CloudFront URL. This gives us the HTTPS and global distribution. Um, the login page. Is a Cognito powered login page. How you will enter your email and password, and then once you guess you'll be prompted to enter your um, MFA code. So just enter it here, 0572. And once you're in the application, um, you'll see all your previous appointments or upcoming appointments. You can find providers, you can see appointments or book appointments. Um, so let's, for example, providers, I will list all the providers. This is hosted in my DynamoDB under providers. So for example, if I only want providers that only work with, you know, United Healthcare Insurance, we could just paste United here and search it, and then it will just show us, those ones, and we can do those for the other ones. So you get the point. So to book an appointment, we could go to book an appointment here, and I will select cardiology as the specialty. And I could also filter by insurance, as we saw in the previous page. And then we could just say find providers. The system queried a DynamoDB through the API and return Dr. Sarah Johnson, a cardiologist. I can see her credentials and accepted insurance plans here. And I'll click on select provider. Now I see her availability for the next I'll see, yeah, for next week. Uh, the Lambda functions generates this 30-minute time slots from 9 a.m. to 5 p.m. On weekdays. And I'll select tomorrow at 2 p.m. And here is my confirmation page showing all the details. I will select general consultation as the appointment type, and I can add notes as optional. So we could just do tests here, but it's optional. And once you click confirm appointments, then you're presented to this screen. This appointment is booked, uh, and we can verify that it was saved. So we selected tomorrow at 2 p.m. So general consultation test here. So this is our upcoming appointments. Past ones will also be listed here, and that's that's how it goes. So to check if this appointment was recently, so we can go to our Dynamo tables here, for example. So let's say appointments. So explore table. So this is the recent one. Yep. Yeah, 16. Yeah. So this is just the one we just did. So it has been created, as you can see here. So it is working. If we also want, we can check the network configuration here. Let's just book another one. Or let's just select something else. Dr. Robert Thompson. So as you can see, we have 200 statuses, which is just basically telling us that the code is working in the back. So this confirms that the web application is working as it should. Um, so some of the challenges in the solutions were so the first challenge I had was the course configuration. The biggest challenge was the course. Initially, my API calls were from the front end. From the front end were blocked. I learned that the course or the CORS must be configured at a multiple levels, and the API gateway resource, and the option method, and the Lambda response headers, and the gateway response for errors. Missing any one of this was caused failures. The other one was the challenge was the React router with CloudFronts, direct URL access to routers like book or returned 403 errors because the S3 bucket cannot find a file in that path. The solution was configuring a CloudFront error page to return index.html, letting the React router handle routing client side. So these are some of the challenges. So cost analysis for this project, I think I would say for development and testing with minimal traffic, this entire stack runs within the AWS free tier. So the Cognito, for example, 50,000 MAU is free. DynamoDB, 25 GB storage. It's still it's free. Lambda, 1 million requests is free per month. So I would say the estimated monthly cost during development at the current stage is probably $1. And then if we scale it up in the future, maybe let's say there is 10,000 appointments per month, and then it would cost around 15 to 25, which is still significantly cheaper than launching an EC2 instance. In summary, I think we have successfully built a fully functional style appointment scheduling system with AWS serverless services. Key accomplishments, I would say, is implemented secure authentication with Cognito FMA, created a scalable data layer with DynamoDB, built a complete REST API with API Gateway and Lambda, deployed React frontend globally, hosted globally on with S3 and CloudFront, set up automated notification reminders. Key learnings. Serverless architecture reduces operational overhead. Proper CORS configuration is critical for web applications. CloudFront caching requires active management, and AWS services integrate well, but require careful configuration. With that, I would like to thank you for watching my presentation, and I hope you have a nice holiday. Thank you so much.